Jai Hind to all. This is Akanksha Shukla from Information Technology Department from AKGEC, and today I am going to discuss one of the topic of data analytics, that is introduction to R language. So basically this particular language is used for data visualization, or we can say for data plotting in terms of analysis of the data, just like we can have a Python language or many more. So basically what are the attributes and data types which are present in the R language? So just opposite to the programming languages like C and Java, in R the variables basically are not declared as some data types. These variables are basically assigned with some R objects. So that's why the objects are very important in R language, and the data type of the R object becomes the data type of that particular variable. So basically we are having the objects in R language. So the objects which are present in R language are vectors, list, matrices, arrays, factors and data frames. So these are the some R objects which are the data types, and they are the ultimately data types of the particular variables, just like we are having a common data type in other languages. So the simplest of these objects is the vector object, and there are 6 data types of these atomic vectors, which are also termed as the 6 classes of the vectors. So the other R objects basically built upon the atomic vectors. So we can say that these are the R objects, and out of these R objects, the most important or the most simplest one is the vector. So in R programming, the very basic data type is the R object, which is known as vectors, and basically this vector holds the elements of the different classes. And in R, the number of classes is not very much confined to only 5, to only the above 6 types. For example, we can have many atomic vectors, and we can have create an arrays whose class will become ultimately the array. So vectors are those when we are going to create the vectors with more than one element, then we should have a C function. So basically the C function is used to define the vectors, which means to combine the element into the vector. So if we are having the multiple elements or more than one element, then we have to use the C function that combines the elements into a vector. So here in this example, the example is given here. In this example, we are going to have a vector creation. So the apple is a vector, but it has the combination of the elements. So we are having the C function, C, and then the elements which we are going to combine into that particular vector. So we are going to combine the elements red, green, yellow. These are the colors for the specific fruit that is written here, apple. So after that, when we are going to print this command, then print apple, then what we get? We get the answer. So when we are getting the class of the vector, then we have to print bracket class, then we have to specify the name of the vector. So when we are going to execute the above code, these two above codes, then we have these two outputs. So when we are having the command that is print apple, then it is going to print all the elements of the C function, that is red, green, yellow. And when we are going to print the class of the apple, then the class of the apple is a character. So these are the basic commands which we are having to print the vectors normally by using the C function. What are the list? Basically, the list in a R object contain the many different types of elements, just like in a Python. In Python, we are also having a list data type. So similarly, in R object, we can contain, if we are having the many different kinds of element inside it, then it is just like vectors, just like in the previous example, we are having the multiple elements and we are using the C function in the vector. So similarly, when we are having the different kinds of element, here we are combining the elements into a vector, and we are having the C function. So here list is a R object which can contain many different types of elements inside it, just like the vectors, functions, and even another list inside it also. So we can combine list inside list also. Okay, so multiple lists can also be reside inside one list. So when we are going to have a command just like create a list, so the list one is having another list which have a vector C, which is a vector having C function, having the combination of different elements 2, 5, 3. These are the elements. So this particular is a one C function, and these two elements are again combining with that particular vector and then forming a list. So in this way, this particular list is having the another list also inside it. And when we are going to print the list, so we are going to print the command print list 1, and when we execute the above code, then what we have in the output? First one is 253 means first of all it is going to print the list 1, which is a vector and having these 3 elements, and second time it is going to print the 21.3, and then again it is going to print the function value, which is the primitive same. So when we are going to produce the result, when we are going to print the command in terms of list, then it is specifying each and every element. The first element is a vector form, so that's why it is representing all the 3 elements of these particular vectors, and in second time individual element is going to be print, and in third time the sign function is having its value inside that particular list, so it is going to print this one. Now what are the matrices? So just like basic in C programming also, we are having a program to print or to add, to subtract, to divide, to multiply the 2 matrices. So just like Python or just like normal simple programming languages, we are also having a R object that is called as matrix. So we all know that matrix is a 2D rectangular data set or 2-dimensional data set. It can be created in this particular programming language. Basically it can be created using a vector input to form the matrix function. So simple like we are creating the vectors, we are creating the list, we are also have a matrix. So what is the command M? Inside this particular M variable, we are going to have a M object. We are having the matrices, and we are going to create a matrix. So in matrix, we are having again we are using C function, and we are having 6 elements. So number of rows 2, number of columns 3. So 3 by 2. This matrix is 3 by 2. We are declaring the matrix kind 3 by 2, and by row is true. Means row wise, row values are true. And when we are going to print this particular matrix, and when we are going to execute the above code, then the result produces this. So here we can easily see that the columns are 3 and the rows are 2. So A, B, and C, B, A. In this way, the first 3 elements are put in first row and next 3 elements are put in second row. So these are the simple commands, or these are the simple methodologies which can be used in R language for providing the object, basic R objects. Now how can we declare, or how can we create the arrays in the R languages? So while matrices are confined to the 2 dimensions arrays, 2-dimensional data sets, basically array can be of any number of dimensions. This is a particular restriction which we are in matrices. So array is apart from these limitations. So array can be of any number of dimensions. So array function takes a dim attribute which creates the required number of dimensions as per requirement, and in this particular given example, we are creating the array with the 2 elements which are 3 cross 3 matrices each. So first of all, we are going to create an array, that is A. Inside this particular array, we are having the C function. In this C function, we are having 2 values, green, yellow, and with the help of dim attribute, we are having another vector that is going to give the values 3, 3, 2. Okay. So when we execute the above code, it will produce the following result, that in first time it is going to have a 3 cross 3 matrices, 3 cross 3 matrices. Okay, because already I have told that in this particular example we are having a array with 2 elements which are 3 cross 3 matrices each. We are having 2 elements and we are creating the 3 cross 3 array. Okay, because these 2 are the elements and dim attributes is creating or it is defining the required number of dimensions. Okay. So, 3 cross 3 matrix, this is representing the 3 cross 3 matrix and 2 is representing the 2 results. Okay. So, means first of all green yellow and then yellow green in this way. Okay. So, when we execute the above code, then we are what we are having the results green yellow, then again repeated the green, and then again yellow green yellow, then green yellow green. Next time when we are having the result, second result, then in this particular result we are having reverse values. So, yellow green yellow, then green yellow green, then yellow green yellow. Okay. So, that's why here in the dim attribute we are mentioning the elements 3, 3 for 3 cross 3 matrix and 2 is representing the 2 matrices. Okay. First one is this and second one is this. Now, next object is factors. So, basically factors are also the R object which are created using a vectors. Basically, the factors are generally created using a vectors. Just like in the list we are having, it is not compulsory that we have to use the vectors. It is not restricted that you have to use the vectors. But factors are the R objects which are created basically by using a vector only. So, it stores the vectors along with the distinct values of the elements in the vectors just like as labels, and these labels are always the character irrespective of whether it is numeric or character or boolean in the input vector. So, they are basically useful in statistical modeling, as generally we can use or generally we are using R language basically for statistics. Okay. So, basically statisticians are having the Python and R languages for their data analysis and for representing the analysis of data into some visualization visualize in some visualization manner, just like in plots or box plots or just like in graphical formats. Okay. So, that the user which are not very much aware about these kind of languages or about these kind of data sets can also easily view or identify that what is the visualization is going to predict. So, basically they are useful in statistical modeling. So, factors are created using the factor functions and the n levels functions gives the count of levels. Okay. So, when we are going to create a vector, then apple color is a just like apple color, it is storing the values of all these which is inside the C function. Then we are having then we are going to create a factor object. Basically, we have to create the factor object. So, when we are going to create a factor object, then we have another value that is factor apple. Inside this factor apple, we are having the factor object that is a apple color, which is a vector. So, this is a vector and this vector is stored into the factor object that is factor apple. Now, when we are going to print the factors, then what we write the command print factor apple and next one is for level. So, print n levels for factor apple. So, when we execute the code, then it will simply execute the values which are provided inside the C function green, green, yellow, red, 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 green, and when we are going to print the levels of this particular factor, then it is going to give the value 3, that is green, red, yellow. Means inside this particular function we are having 3 values green, yellow and red. So, this particular function and level is going to predict the count of the levels, that how many elements are, how many we cannot say that how many number of elements, number of level it is counting, because number of elements is 7 inside this particular function, but the level is 3, means the level of particular data which is providing inside the C function is 3. Now, what are the data frames? Basically, data frames are the tabular data objects. Just unlike we can say that in a matrix, in a data, don't like in a matrix, in data frame each column can contain different modes of data. So, first column may be numeric, then while the second column may be character, or third column may be logical. So, this is not, there is no similarity. We can say that there is no similarity inside the data. Okay, so it can have a different modes of data. It can have a numeric value, it can have a logical data, it can have a character data. Okay, so combination of different kinds of data we can put inside of one data frame. So basically, it is a list of vectors of equal length, and they are created using the data frame function, that is data frame this. So when we are going to create the data frame, create the data frame. So BMI is storing the vectors which are having the different modes of data. So this data frame is a vector. Inside this we are having a gender, height, weight and age. These all are the values. So these are the, basically we can say that these are the vectors, and inside these vectors we are having a C function. So in gender we are having a C function which have a combination of male, female. Okay, in height we have a C function, have different values. Weight have a C function, different values. Age having C function, different values. So these are the vectors. Okay, these are the vectors basically. Okay, and the combination of this is basically decided into a data frame function. So basically this is a data frame function, and inside this function we are having a vectors of different modes of data. So when we are having the print command, or when we are going to execute this particular command, then we are having 3 results in tabular format. So gender, height, weight and age, these all are the information. This is the information basically this data frame contains. So in simple way we can say that data frame is a collection of data, and inside which each column have representation of different modes of data, which can be in a character form, which can be in a logical form, which can be in a numerical form. Now, what is descriptive analysis in R programming? Basically, we are describing our data with the help of some various representative methods, just like using charts, graphs, table, Excel files basically, and many more. So, what we are having in descriptive analysis, basically in descriptive analysis, we are going to describe the data in some manner, or when we are going to present the data in a meaningful way, so that just as I told earlier, that we are going to present the data in such a way that it can be easily understood by the person who is not very much information, or who is not very much aware about all these kind of things. So most of the time what we do, most of the time it is performed on small data sets, and this analysis helps a lot to predict some future trends based on the current findings. And some measurements which we are going to use to describe a data sets are the measures of central tendency, variability or dispersion. So these are the basic measures which we are having in descriptive analysis, just like measurement of central tendency and measure of variability. So what we are having, there are basically 2 types of statistics, descriptive statistics and inferential statistics. So in descriptive statistics we are having a measure of central tendency and measure of variance. What is measure of central tendency? Basically it represents the whole set of data by single value, and it gives the location of central points. So basically there are 3 terminologies which we are going to use to measure this particular central points. These are the mean, mode and median. Okay, so mean, mode and median. So mean value is basically this is the mean value, means we are having the average of all the data points of all the data values which we are having in the particular data set. What is the mode? Mode is basically the frequent occurring, or we can say that how frequent, which item is mostly frequently occurring in the particular data set. What is the median value? Median value is the simple, which suppose we are having a 12 elements or 6 elements or any number of data points. Okay, so median is the basically mid value. Median is basically the mid value. Okay. So these are very basic things. These are the very basic terminologies which we already have knowledge about all these things, and that what is mean, mode, median, basic mathematics. And then what is the measure of variability? Basically, measure of variability, we can say it is known as the spread of the data, or we can say that how well our data is distributed. So most common variability measures are range, variance and standard deviation. Okay. So that how much the range of particular data, how much particular range, we can say that in graphics, or in when we are going to have a graphs in mathematics, then we are having the data sets in which we are having the ranges, that particular data set lies between the range 0 to 5, 5 to 10, 10 to 15. So these are the ranges. Okay. So why we are having this particular descriptive analysis? Why need of this particular descriptive analysis? So basically, this descriptive analysis helps in identifying or helps in understanding our data, and it is very much important for the machine learning, because machine learning is all about making the predictions. So basically, predictions can be accurate, more accurate, when we are having the better understanding of the data. When we are having the better analysis of the data, then only we can predict the future trends in a more accurate manner. So on the other hand, we can also have statistics, which is all about drawing the conclusions from that particular data, which is also a necessary, or which is also a very primarily step for machine learning. Because if we are having the statistics of that particular data set, then it can also helpful in predicting more accurately. So what is next step? What is exploratory data analysis in R programming? So basically, EDA is a statistical approach, or which or technique which can be used for analyzing the data sets in order to summarize the important and main characteristics of the data by using some visual aids. So this particular approach can be used to gather the knowledge about the following aspects of the data, and the data have some features or some characteristics. So basically, this approach is used to identify that particular features or that particular characteristics, just like what are the different variables, what are the relationship between the attributes of that particular data, of that particular variables, or the attributes which are present in that particular data sets. It can also helpful in finding the important variables which can be used for our problem. Just like for example, we are having we have to identify that what is the highest percentage holder in our class, who will be the highest percentage holder in our class. We have to I have to predict that particular student. So what are the basic attributes? Suppose I am having the complete data from the college. Okay, but at that particular point of time, I have to identify only the highest percentage holder of that particular section. So I don't have to collect all the whole data of the college. So to find out the important variables which can be used in our problem that time, it can also be very helpful. Generating the questions about our data, searching for the answers by using visualization techniques, transformations, and by modeling the data into more better way, using the lessons which we are going to learn in order to refine a set of questions or to generate a new set of questions. So basically, exploratory data analysis is useful in this particular basically in identifying the main characteristics of or features of the data. So when we are going to implement the R language, then we are going to perform EDA under two broad classifications. First one is descriptive statistics and second one is graphical methods. So in descriptive statistics, which I had already told, that we have to identify the mean, median, mode, interquartile range also, and all these things. And in graphical methods, we are having a histograms, density estimation, box plots, tree graphs, heat maps, and these are so many visualization techniques or graphical methods are present, and we have to use that. So some of the various type of visualizations which are offered by the R are bar plots, histogram, box plot, and scatter plot, and heat maps. So in my next video, I will come with you with some more basic information about R language and how to use the R language and how we can have these particular graphical methods implementations. So in my next lecture, I will come with all these things. That's all for today. Thank you.